Welcome, everyone. Hopefully you are enjoying Microsoft Fabric Global Conference. So let's kick off this session, the Direct Lake in Fabric, Advancing Semantic Models Behind Import and Direct Query. If you have any questions, please post it on the Q&A. If I'm able to have time in the end, I will try and answer as much as possible. But please apologize in advance if we are not able to cover everything within this session, but hopefully we will have some time in the end to answer some Q&A. So about myself. So my name is Miguel Félix. I'm a lead BI architect for the last year. I have a background in finance. I worked in the finance department for almost 20 years, and around 3 years ago, I was invited to be a consultant in Fabric because I was working with Power BI since 2015, so the beginning of Power BI, and I always was interested in this data area, and then I got the invite to come to consulting in this area. I'm currently a Microsoft Data MVP. Also, Fabric MVP this year was also added to the category Power BI and Fabric. I'm also a super user at the Fabric community, so I've also been engaged within community for almost since the beginning, not 2015, but I think it was around 2016. And I also have my own blog post, and I'm also part of Fabric Power BI Portugal. It's a meetup here in Portugal where we do presentations about Power BI and Fabric. Every month we have at least one online and some also in person. So that's basically about myself. So I've been in the data world and especially on the Power BI side for the last 9 years. So, and this has given me a lot of knowledge on what is possible or not. It also allowed me to learn a lot with everyone in the community because it's a very active community, and also to be aware of the small things that we may encounter that will impact our path within the data world. So, but going to specifically to the session of today, what will be our agenda? So we will talk a little bit about the One Lake, the main concepts and the Parquet files. You will understand why we will talk about this One Lake. Then, what is the Direct Lake? What are the main concepts of the Direct Lake? What are the main problems that we may encounter? What are the limitations? There are also some limitations. And then we'll do a demo, basically looking between Direct Lake and Direct Query so that you can understand what is the main differences and what is the main impact that we have using one or the other in our semantic models. So starting by the One Lake. So this is the Microsoft ecosystem, has been around for some time. Previously, we had this all of these workloads, the data factory, the data engineering, the data science, the Synapse was all scattered through different types of apps. But currently, Microsoft with Fabric has integrated this. The One Lake is one key aspect of Fabric, and basically Microsoft presents this as the one drive for data. Why? And let's do a small comparison. A few years ago, when we wanted to share a Word document, an Excel file, usually what we do is we did our work and we send it out by email, and then someone would revise it or change it or update it, resend it by email or store it in a server somewhere. And all of a sudden, instead of having one file, we would already have 20 versions of the same file, and we would not know which one was the latest one. Or even if we did, we would not know if that information was updated according to the latest information, because someone could be doing a change based on the previous version, and we would not be aware of that. with the OneDrive and similar processes and similar apps that came along, we got to a point where we store our documents into OneDrive, and then the editing of those documents is done online sometimes, or even if it's offline, we have a clear idea of what was the update of that information, when it was updated, by whom, what type of changes were between each one of the of the of the versions, and so on. In this case, OneLake is exactly the same thing, but instead of picking up Word documents, for example, or emails or whatever information we put there, it's driven for the data. This means that we can store not only our Excel files, because they are also data, or our Word documents, but also databases. We can do connections to different types of things, to different types of information. We can have data flows saving our data into the OneLake. So this means that we have a single location where the data is stored in a single common format. That format is the Delta package. So when we store our data into the OneLake using the warehouses and the lakehouses that are available into Fabric, the files are there stored in the package files, in the Delta package files. However, the OneLake also allows you to store files in any format you want. So you can also store in the OneLake specifically, you can store video files, you can store Excel files, CSVs. But when we talk about the data that is being consumed for Data Factory, for Power BI, for Data Activator, for Synapse, we are talking about information that is stored in the Delta package files. So, and once this data is stored in the OneLake, it's directly accessed by all these engines in a very straightforward way and very direct. So in this case, we have not only the file saved on a single location, and they can be also consumed, since we are talking about Delta package files, they can be consumed in a different way. So we can have Spark, we can have T-SQL, we can have TQL, we can have analysis service. So depending on the type of information you are accessing and the tool you are using to access the OneLake, you have different options to go to that information that is stored in Fabric. Also, in terms of the OneLake, we have two ways of two layers. So in the left side, you can see the Fabric workloads. The Fabric workloads are optimized to ingest data from the OneLake. Why? Because they are part of the Fabric ecosystem. So this is the Delta package files that are optimized to be written and read with a good performance. They are even more optimized when we are talking about the ones that are saved on the OneLake being consumed by the Fabric workloads. However, this OneLake is not self-contained, is not closed from outside. It's not closed for external tools, for example, Databricks, Azure, AD Insights, or other applications. And using an API, you can ingest your data from the OneLake. Why? Because Delta package format is a format that is open source and that is used in different ways. Let's look then to the package files. So package files structures your tables. As I said, we are looking into the information that is stored in the warehouses and in the lakehouses. So we have it stored as structured tables within Delta package files. These files allow for a high volume of compression, that because of the encoding that they have, and they are also a columnar storage. So this means that each file is organized by columns rather than by row. We will see a small example so that we can understand a little bit about this. And in this case, each column is a separate entity, meaning that each one is physically separated from other columns. We are talking about inside the package file, of course, but the engine can then scan only the columns that are needed in each query. This allows to skip unnecessary columns and improve the performance of your analytical queries. For example, if you look at the CSV file or at the database, when you do a query and when you refer to any information that you want, it is validated through the line, through the row you are looking at. When you are talking about Parquet files, and if you do the comparison that you would apply a where clause on SQL, when you do that where clause in terms of these Parquet files, it will only pick up those specific columns that you need. So this is a very good performance optimizer. And then it's language agnostic, so developers may use different programming language. As we saw previously, we can use KQL, we can use T-SQL, we can use Python, we can use Spark, and it's open source. Being an open source, then this also brings out a very big question. There is no vendor lock-in. It's also is always a question when we try to use this type of new software as a service, new dependencies on a software provider, is how locked in am I to that specific format. In this case, using Delta Parquet files, it's open source, no vendor lock-in, and we can pick those files and just store them anywhere else if we want to move away from the one. And then it supports complex data types. Let's look a little bit at the Parquet files and how they work. So this is an example that I took out from Data Mozart. Nicola, he has it on his site. I'm not an expert, as I said, my background is in finance, so I'm not an expert in any coding language or any of this, but I was able to pick some things during the last years. And this example from Nicola is a good example to understand how Parquet files work in a high-level option. So, as I said, this is a columnar storage, and as you can see, we have over here a small file that has 5 columns, so product, customer, country, date, and sales amount. And in this case, as I said, if we're trying to see the sales by country, the only thing that when we did the query to these files using the OneLake or using Power BI or whatever other type of tool you want, if I search for the sales by country, what would happen to this file would that when I do the scans, instead of doing Ball, John, USA, and then, okay, this is USA, it's $100. Then we go to T-shirts, USA, again, $200. When we do the scan to this, we only pick up the column 3 and column 5. This makes it much faster. Why? Because then I only have to scan through, although I have to scan through all the rows, the indexing that is behind allows it to quickly identify all the cells for the USA and for the UK and do the calculation pretty quickly. Also, on top of this, and to add some complexity, there is some row groups. The row groups are currently in Fabric. They are done in an automatic way. You don't have any way to define the row groups inside the Parquet files, at least to my knowledge, okay? And row groups are defined immediately inside your files when they are being built, when you are storing your data into the OneLake. And as you can see, for example, we have 3 row groups, and in this case, if we continue to have the information, and now we want to have our information by product and by sales amount, we go to this Parquet file, we look at it, and we search for column 1 and for column 5. However, having these row groups allows them also to be scanned much faster. So in this case, if I want to look at what are my sales for T-shirts within this specific file, you can see that in row group 1, we have T-shirt. In row group 2, we have only socks. And in row group 3, we have again T-shirt and socks. So this means that row group 2 can be skipped altogether and just doing our query into row group 1 and row group 3. This makes an optimization of the process. How does this happen? This happens because on top of the Parquet files, there is all the metadata that we have into our file. So it's not only the information that we have that shows up talking about the information by itself. So every value that we have, and if you go to the previous slide, you can see, for example, in row 1, it's not only ball, John Doe, USA, 2023, 100, but it's also the information about each one. So each column has its own its own information. Inside that information, we have the type, the encoding, the offsets, and inside that information, that metadata, we are able to do an indexing. The indexing is done automatically, and it's able to be much faster and much consumed quicker. Again, optimized version for this raw data, or even for enhanced data that you have. As we said, this type of files support complex data types. Okay, so we now have our foundation. So our foundation is the one lake, and we have our files stored in the Parquet format. The Parquet format, I remember, it's a columnar format that allows you to have different different approaches to it using different types of languages. And what is the direct lake? So let's see what is direct lake in terms of fabric, and how does this make our reporting options much more performant. So before having fabric, we have three main types of modeling. So we have the import mode. The import mode is a very fast reporting from the perspective of the load of the data into our report. Why? Because when we do import mode, basically we are copying our data from our source data and saving it on our data set. Those data sets are then consumed through Power BI, for example, and on our reports, and the consumption of that information inside our reports is done using DAX queries. Although it's a very complex language, in terms of the utilization inside import modes, it's very fast, and the VertiPack engine allows to have a very performant model. Problems with this, it's duplicative. So when we do import, we are duplicating our information. As you saw previously, the one lake, the idea is not to have more copies of our data, okay? It's to have a single copy of our data, to have as we said, the one drive for our data, and it's also latent. This means that anytime that we want to see the latest information, we have to wait for the refresh of the data. This refresh can be scheduled or can be manual, but there is always a latency. To reduce this latency for the import mode, we have, for example, the incremental refresh that allows to have a specific time frame where we can just pick up the latest information for the past month, year, and so on, but it's still latent and duplicative. The other option is direct query mode. Direct query mode, it's slower when compared with import mode. Why? Because when we talk about direct query mode, we are talking that we access our report and we do DAX queries into our data set. But our data set is nothing but metadata information. This means that we have all the information about our table, so we know the names of our columns, we know what type of data they have, we know all the relationships, everything is set up in the exact same way as we do in the import mode. However, when we run our queries into our data set, they are then transformed into SQL queries. So we start by having a visual. That visual is transform into a DAX query. That DAX query runs on top of our data set, picks up the metadata information, and transforms that into SQL queries. Those SQL queries are then run on top of our data sources, and then they get back to us on our report. So this is real time or very near to real time, but it's slow. Why is it slow? Because again, we have all this process in the middle where we are transforming DAX queries into SQL queries, and then SQL queries are returned into our reports. This can be seen using, for example, DAX Studio, where you can see our DAX queries transform into a SQL query, but it's slow. But again, it's real time, and when you are talking about a large amount of data or information that you need in very short amount of time, then this is a good option. And as I said, we have 3 of them. The other one is the composite models, where we have a mix between import mode and direct query mode. So for the fact tables, usually we have direct query mode, where we have the big calculations, where we have tables with large sizes. And then for the dimension tables, or the ones that are not so don't have big changes on the data, we have import mode. So, and this was the state of the Power BI datasets before Fabric. With Fabric, now appears a new option, that is the Direct Lake mode. So the Direct Lake mode is an option that tries to take advantage of both options, of both previous options. So if you look at this, if you look at the dataset is once again only configured at metadata only. So we have all the basic informations of our data, the column types, the names, all of that. In our reports, we run DAX queries on top of our reports. However, these DAX queries, instead of being transformed into SQL queries, they are run on top of the Parquet files. This allows to have to scan our queries much faster. As I said previously, if we look at the specific sales by country where we are only picking up the information for country and for sales. We are not picking up all of the other columns we have on our model. So this makes this information much faster than we have direct query. So this is overall the best of import and direct query for high scale and real time. This does not mean that we should abandon import mode or direct query mode. No, direct lake mode is another option that we have and that can be used on top of your semantic models and of your data. However, again, if you have a model that is working on import mode, there is no need for you to go immediately to direct lake because, and you will see the difference between one and the other one, between direct query and direct lake. Import mode, we are talking that direct lake and import mode have similar times in terms of performance. But yes, you don't go everything to the direct lake mode yet because it's not needed. It's just another option. Someone is asking if the lakehouse and the warehouses reside in the one lake. Yes, the lakehouses and the warehouses are on top of the one lake. Yes, so it's how you can organize your data inside of the one lake. So as I said, the one lake allows you to have not only information that is structured as you have these Parquet files, but also unstructured data like video files or something like that. Available on our Fabric. So we have a semantic model capability for analyzing large volumes of data. It's based on loading Parquet files directly from the data lake without having to query the lakehouse or the warehouse. For those that are not aware, we can query the lakehouse or the warehouse using a SQL endpoint. And if we use that SQL endpoint, then we go to a direct query mode. But when we do this direct lake engine, we go over, we go around the SQL endpoint and just consume the data from the Parquet files. So this eliminates the import requirements, again, that question about the duplication of data, and there is no translation between DAX or NDX to any other languages. So those are read directly automatically. Any data changes that you have on your one lake, it's automatically reflected on your reports. So if you are in the middle of the day and someone updates your data, you immediately see it reflected on your report. It's available for lakehouses and for warehouses. There is a SQL endpoint, as I also referred, so you can always revert back to SQL. And using the XML endpoint, you can also use external tools like SQL Server Management Studio, Tabular Editor, DAX Studio, and so on. And then there is a question about fallback, and this we will talk right after. Why? Because although this model is very performant, there is limitations based on capacity. And then depending on the capacity that you have in Fabric, you may hit those limits much sooner. This means that instead of having your model in Direct Lake always, you will fall back into Direct Query. So let's see a little bit about this. So in terms of Direct Lake, we have this small table that is on Microsoft's website, and we can see that depending on the SKUs that we have, there is different types of operation. So the orange part is where we talk about the guardrails. So the guardrails is what we call it's what defines the limits for Direct Lake mode beyond which there is a fallback to Direct Query mode. This means that all the queries will be processed through the SQL endpoint. And then we have the blue part that is highlighted over here, that is max memory. This max memory that we have over here, basically is similar to the import mode, okay? This does not have any impact on your Direct Lake options, but it's also something to keep in mind. But let's look at very quickly before we go to our demo. Let's look at what are the limits that we have that can set a fallback from our Direct Lake to Direct Query. So the first one is Parquet files. So when we store the Parquet files into the lakehouse, automatically it's generated 1, 2, 3, 20, 100, 1000 Parquet files. Those Parquet files, each time you save, it's optimized. You can even run some optimization in the background that allows to reduce the number of Parquet files and the size of the Parquet files. Be aware that unlike other types of files, Parquet files, the bigger, the better. This means that if you have a large Parquet file, it's much more optimized than having several small Parquet files. But if you create a table, and that specific table, and be aware that this limit is per table. If you have a table, and if you are running a F64, and that specific table has more than 5,000 Parquet files, your queries to that table will fall back to Direct Query. We will see this in our demo a little bit more in detail, not talking about Parquet files, but talking about rows per table. Then we have row groups per table. As I said, the row groups, we have no way to define them in our settings. So it's automatically done when we create the Parquet files. But the limit, as you see, it's the same. So per each table, if we have more than 1,000, for example, for F2, if we have more than 1,000 row groups, then we'll have a Direct Query fallback. And then rows per table. This means that if you have a table that has more than 300 million rows and you are at any capacity below F64, you will have a fallback to Direct Query. So this means that when you do a visual running on top of one table that has more than 300 million rows, instead of using Direct Lake, that is not possible, and the report falls back to Direct Query. When we are talking about everything below F64, there is also the size of your data model, of your semantic model, that needs to be smaller than this 10 gigabytes, 20 or 40. Okay, so some things to keep in mind because sometimes when we start to work with Direct Lake, we think that everything is very fast, and all of a sudden there is a specific visual that is running slow. We don't understand why, and sometimes it's because we are hitting these guardrails and everything is falling back into Direct Query. Before we go to our demo, and really quickly, so we have our issues and limitations. So some of them are highlighted over here. So currently, we can only work in Direct Lake mode with tables from one single lakehouse or warehouse. We cannot use composite models, aren't supported for Direct Lake. Calculated columns and calculated tables are also not supported. Tables, if you create views on your warehouse or your lakehouse, they are not supported in Direct Lake mode. Why? Because views are run through the SQL endpoint and then run on top of the files. When you run the views, it's a SQL, and then automatically turns on the SQL endpoint, so no Direct Lake because it cannot access the files directly. And then there are some other things like specific data types are not supported. Direct tables do not support Direct Lake tables do not support complex delta table columns like binary or GID semantic types. But overall, it's a very complete process. And these issues and limitations are always being updated on the Microsoft documentation. So be aware that, for example, one of the beginner at the beginning of this process was that Direct Lake would not support row level security. Currently, is already supported. So this is evolving as people move ahead in Fabric. So let's go to our demo. As I said, it's a demo between Direct Lake and Direct Query. So let's start by going over here to Fabric. And I have over here, let me just show you. I have in my, apologies. I have a lakehouse, and in this lakehouse, you can see that I have a couple of tables. So I have a calendar table. I have a big table, a yellow cab big table, a yellow cab medium table, and then this yellow cab company that is a smaller table. If we look at the information we have over here in this model, basically, as you can see, all these three tables are connected to my calendar using some two relationships. So basically, it's a basic thing. And we have a couple of measures over here. And one that I have in all of them is my row count. So if you see all of this, this is just count rows of the big table, the medium table, and the small table. This model also, be aware that when we look at this, as I said, we are not able to do calculated columns or calculated tables. And in our model, if you go over here to the model tab, if you go to semantic model, you can see that we have over here the Direct Lake behavior currently is on automatic. Okay, so this is just a small information about what we have over here. If we go to our tables inside, if I just pick up over here my lakehouse, and if I, as you can see, I'm currently on that lakehouse. If I run this, you can see that I'm able to access the lakehouse information. Okay, this is important because there isn't a way for us to see what is the if a specific table or a specific lakehouse. Sorry, I need to run. First of all, I need to run this pip install. If a specific table within our lakehouse will fall back into direct query or not. Okay, but we'll see this in a few minutes. Let me go to Power BI. And so as you can see over here, we are connected to that D-Lake multiple table. So let me just go back over here. So this is my semantic model, and we have the three tables. So the first one, as you can see, is our big table, and we have 1.6 billion rows. The second one is the medium table that is 1.3 billion rows, and then we have a small table that only has 76 million rows. If you remember the guardrails that I highlighted previously, when we are talking about an F64, and I'm currently on the trial version, so I'm on an F64, my guardrail for the rows per table is 1.5 billion rows. Okay, so let's look at what is behind the scenes on this. So we have just these measures, so the small measures, like I said, that we have over here, the row count. Okay, all of this is based on the row count, nothing more. And then we have the table where we pick up specific calculations. Okay, nothing special. We're just looking into the data. Now let's look what is happening behind the scenes. So let's turn on the performance analyzer. Let's start recording and let's do refresh. And now let's see what is happening to our data. As you can see, the visuals that are refreshing are the ones that are connected to the semantic model. Everything else is just text. And as you can see, this is running. This is taking a little bit longer, but this table large is the one that is taking longest. Okay, let's start by looking at our cards. Okay, let's start by looking at the card small. If I open the card small, you can see, let me just turn on zoom it, please, so that we can have a little bit more. You can see over here that we have text query, we have our visual display, and then our others took a little bit longer. Okay, let me just clear this and rerun the refresh. So, okay, much faster because of the others. There was a question because I had this turned on for quite some time. Let's continue over here with our card small. But as you can see, this only has text query on top of this. Okay, so let's look at our card medium. If we look at this card medium, we see exactly the same thing. So we have our text query, we have our visual display, and then we have our others. Okay, pretty good, no problem. Let's look at our card large now. Okay, if we look at our card large, we can see that this is a different one. Okay, as you can see, we have over here our direct query. So what does this mean? This means that this specific visual has fall back into direct query mode. What is the difference between this card that is over here and these other two cards? Is that these two cards are directly being accessing the Parquet files underneath. So in this case, I'm just counting the rows. If we look at our card large, what we are running is a direct query. So this means that the calculations that are being done are being transformed into SQL. The SQL endpoint is then picking up the information and returning our 1.6 billion row count. The same happens for our tables. So if you go to our tables, if we start by our small, we only have DAX query, our medium DAX query, and our large, we have direct query. So let's look, how can we impact this? So let's just do the following. Let's go back to Power BI, to Fabric in this case. Let's go back to Fabric. And let's go over here to the lake behavior, and let's change this to direct lake only. So this means that when I run this, everything is going to will be read directly the information from the Parquet files. Okay, So let's look what is the impact of making this change in our report. So if I just go over here and do a refresh of my semantic model, a small refresh, you will see that everything is running, everything is loaded. Even if you look at the times, they are pretty fast, as you can see. But however, this top table is not working. Why? And it says over here, we could not process the request because of fallback to direct query. So since this table has more than 1.5 billion rows in this case, it automatically reverts back to direct query. Since we are forcing the data to be in direct lake mode, this visual won't load. But let's look at one thing. Let's refresh this once again. Let's look at the times that we have over here for the other visuals. If we look at our card median, 784, if we look over here, we have 1433. Let's refresh one more time, just quickly. 843. So the information is getting updated. And if you look at our table, we have 1898 milliseconds. Previously, it was 2371. So the information is getting loaded pretty fast. Let's do one thing. If we go over here to our model once again and put this in direct query only, let's see what happens to our data. Let's do a refresh. And now let's see what happens to our data. So as you can see, this is already taking a few seconds more to refresh, especially the tables that have more information. Just for you to see, as you can see, this is taking more than 10 seconds. Why does the large table loads faster than the medium? Because over here on this large table, I did a filter, okay? It's just because if I had the full information for the large table, it would take even longer. As you can see for the table medium, we don't have any filter and it's taking forever to run, okay? So this is how we can see immediately what is happening behind the scenes to our direct lake behavior, okay? But let's see a little bit more what is happening behind the scenes. When we are running this, and let me just put this in automatic once again. Let me just refresh. When we are running this, and as we saw, things are. Let me just clear this and rerun. Things are running pretty fast, as you can see. If I run again, you can see that the times for our cards, for example, card medium is 531, goes to 383. If I run it again, my card medium stays around 400. So we have a decrease in terms of our first load when compared to the second one. If we look at the tables, that is even also visible that we have some performance improvements. In this case, the visual is not that big, so we won't see those big performances. But let's look what is happening, as I said, behind the scenes. There is a feature, you can use Semantic Link, and Semantic Link allows you to get information from your semantic model and understands what is happening. And one of the things that we can have in terms of our semantic model is the temperature. What is the temperature of a column? The temperature of a column is, and I don't know if you already have heard about this, there is one, when you use the information over and over again, so, and if you are always using the same information, if you are always doing queries on top of the same information, the engine, the Vertipack engine, maintains that specific column. If you look at the specific column, always as odd. So it's always being referenced. So it's always being on top of the quick loads. So this going through the direct lake. So if we are running always on top of the column here, for example, that column is accessed 1 time, 2 times, 3 times, 4 times. It's always kept odd. As the time goes by and we don't use it on any query, on any visualization that we are looking at, this temperature goes down. Let's just run this this evaluation of DAX. Being DAX, this means that we can run this using DAX Studio. For example, this information is also accessible through DAX Studio without the need to run any DAX. There is an option there where you can see these definitions already on the DAX Studio. Sorry, let me just rerun over here the semantic link. Sometimes this happens, we have to rerun it manually. Hopefully this will run fast. Okay, this already run. And now let's see what we have over here. If we look at our temperature, you can see that, and this takes a few seconds, this will give you a table with all the columns that we have in our semantic model, and the ID, the segment number, the record count, the resident, the temperature, the one that we are looking at, the last time that it was accessed. In this case, as you can see, and let me just sort this from largest to smallest, we can see that, for example, over here, the median table, the tip amount is one of the top ones. Almost all of them have the same temperature because we have been playing around with that specific table. But if we sort this from the smallest to the largest, you can see there are a couple of things that are not even used, right? So the location ID, the row number, etc. So, but let's do a small test over here for you to see what is happening. So let's go back to our report. Let's add over here a small table. And on this table, we will have our year from the calendar. Let's do this as a don't summarize. So we have all our years. So we just added the year over here, and let's rerun this this DAX syntax where we can get the information from all our columns. As you can see, the top one that we have now is our calendar year. This is the hottest one. So this means this was what was run the latest. So if I go over here, for example, and if I just do a refresh of this specific visual, when we run this again, if we run this again, you can see that the numbers for the temperature previously, so we have over here 186, and this one is 48. So all of this, let me just pause the visuals, and let's go to this one. Let's just let's just refresh the visuals once again. Let's see if this is refreshing. Okay, so now if we run this once again, we have our, do you see? Now it's 1.78. So the numbers is the more you see, the more you interact with your model, the hottest it is. Hot columns means slower slower time to load your visualizations. But okay, we are seeing this. All of this is we are using Performance Analyzer, we are using DAX Studio, we are using a notebook, but you may want to understand if this is happening behind the scenes before you run your model. And for that, and to finalize our demo, there is a new option that is Semantic Labs, Semantic Link Labs. And this allows to connect to your semantic models and running your information on top of your lakehouse. This information on top of your lakehouse has not only all the information for all your tables, but these labs also added these two options. One is the extended one, the other one is count rows. This means that the second one, as it says, it counts the number of rows that you have, and the extended gives you information if that specific table will fall back into direct query and why. So this means that we are going to compare our semantic model to our capacity, and then based on that we are going to see, okay, this is on F64 and we have a table that has 1.6 billion rows. This is higher than the 1.5, then this will fall back into direct query. If we have, in this case, we don't have, because as I said, the model is not that large. If we have a specific table that has more than 1,000 files or 5,000 files, depending on your capacity, it will fall back if that is bigger than your guardrails. That will fall back into your to your direct query. This extended option will show you that. This means that you can monitor your fallback, your guardrails, and then on top of that, you can continue to monitor. This has even an option to extract this information into your lakehouse. Once again, you can do a new table inside your lakehouse with this information, and you can do, for example, a Power BI report that does this monitoring for you. And why? Because let's assume you have a daily refresh of information. A table that today is not is working perfectly in direct lake. Tomorrow, because of the number of rows being exceeded, it can fall back to direct query. You will have issues because your users will tell you, oh, this is very slow. Why is this happening? Instead of losing time looking for the answers, running performance analyzer, sometimes just running this small code will help you understand, okay, wait, I have an issue because this specific table, this specific identification has more lines than we should. As you can see, on the left, we have the Parquet files guardrail, the row group, and the row count. As you can see, the only one that we have true is this one. That is our big table that has the 1.6 billion rows. As you can see, it's exactly the size that we saw. This number matches the card that we have over here, 1.6775415. And so this is one option for you to check your direct lake mode if it's still running properly or if you have any other issues. If you have any questions about Semantic Link and some Semantic Link Labs, there is a couple of sessions online done by the team of Microsoft that is developing this. Okay, so what are the advantages and the use cases that we have? So advanced data processing, optimize real-time access with improved performance, and unified data management. These are three of the major ones. In terms of use cases, for the financial sector, where they have billions and billions of rows, for supply chain also, health, so everything that has a huge amount of data and that you need quick access, that you need real-time analytics almost, so real-time analysis, not analytics, because there is an option for real-time analytics in Fabric. So this is a good option for Direct Lake. As you saw, there is a lot of difference between the time that the information is getting consumed and seen on your report and the one that you are working on. We saw that in the medium table, where when we run it in direct query, it took forever to load all the information. And probably that specific table would also got into the limit of the 100 million row limit for that specific visualization. While when we are in direct lake mode, that limit is not reachable. A special shout out to Sandeep from Fabric Guru and Nicola, because they helped me to get this part of this information gathered. You have my contacts over here. I don't know if there is any questions that you have placed on the Q&A or on the chat. Let me just check really quickly. Okay, how can I edit Direct Lake semantic model? I'm unable to use Power BI desktop update to the model. So Direct Lake models can only be updated on the service. This means that you can only use this option over here to make the update of Direct Lake models, to add new measures, to add to do relationship and so on. But not quite. What do I mean by this? You cannot use desktop mode, but you can use XML endpoint. So you can use external tools. So you can also update your direct lake semantic model using SQL Server Management Studio or Tabular Editor, for example. Paid version or paid version or free. Okay, so you can do in three ways: in the service, and using external tools. Be aware that either way, the DAX columns are not available, nor the DAX table. Okay, you can add measures, DAX measures, but you cannot add tables. Can we have access to this demo? No, I don't have this. I don't have this demo. I can try and record this data, this demo, and then share it. Please reach out to me through my LinkedIn, and we can have that arranged. Okay. I don't know if you have any other questions. If not, it was great to do this presentation for you. I want to do a special thank you to David for having me, for helping organize all of this. A big thank you to everyone also to join me on this session. Stay tuned for the rest of the session. We are just starting the global conference. There is a lot of nice sessions coming up. And again, feel free to reach out anytime that you want. Okay. Thank you, everyone. Hope you have enjoyed.